All right, everyone, today we're going to do something a little different. We're not just looking at a traffic camera, we're going to deconstruct the entire expert blueprint for an AI-powered enforcement system. Yeah, we're going to think like the actual architects who build these things, right from the ground up.
So let's just dive right in. Here's how we're going to break it all down. First, we'll look at the old way versus the new way. Then we'll walk through the actual AI blueprint piece by piece. After that, it's time to put on our engineer hats and go through an architect's checklist. Then we'll see how this whole thing actually gets rolled out in a real city. And finally, we'll talk about why any of this really, truly matters.
Okay, first up, Section 1. We're talking old school versus new school enforcement. I mean, look, before you can build a solution, you've got to understand the problem you're trying to solve, right?
And this slide, wow, this just lays it out perfectly. It shows the massive shift. On the left, you've got the old way. Slow, manual, totally dependent on a police officer happening to be in the right place at the right time. But look at the right. The AI-powered future, it's a continuous, automated loop. This is a huge deal. It's about moving from just reacting to violations to actually proactively shaping how people drive in real time.
All right, let's keep moving and see how this thing is actually built. Welcome to Section 2, the AI System Blueprint. You can really think of this as the digital assembly line that makes this whole automated enforcement thing even possible.
So, if you were the architect designing this is the journey the data would take. It's a 5-step process. It all starts with the data sources, the system's eyes on the street. That data then gets streamed and ingested for processing. Then the key features are pulled out. Step 4 is where the magic happens. The AI detects a violation. And finally, a decision is made and an action is taken. It's this beautiful, seamless pipeline, all the way from the camera to the citation.
Okay, so let's start at the beginning, the data. Everything, and I mean everything, starts with high-quality inputs. And we're not just talking about one camera here. A smart system actually fuses data from a bunch of different sources. You've got your ANPR cameras, that's automatic number plate recognition, which are specifically designed to read license plates. Then you have your regular CCTV, which is watching for the actions like someone jumping a signal. And you even have IoT sensors that know if the traffic light is red, yellow, or green. When you put them all together, they create this complete, rich, digital picture of exactly what's happening at an intersection.
And now we get to the really cool part, the AI engine itself. This is the brain of the whole operation. It really boils down to a 2-part process. First, you've got computer vision models. You might have heard of ones like 𝗷𝗚-V8. Their job is to detect and find the vehicle in the video. Then you have optical character recognition, or OCR, which zeroes in and reads the license plate. The engine then takes all that data, combines it with context, like, hey, the light was red, and then bam, it classifies the violation. So in a nutshell, it sees the car, it reads the plate, and it understands what happened.
So what's the output of all that brainpower? Well, it's this. And this is so important. The AI's final verdict isn't some blurry photos someone has to review later. No, it's a perfectly structured piece of data. Look at it. You've got the vehicle number, the exact violation, a signal jump, the AI's confidence level, which is a really solid 94% here, plus the precise timestamp and location. But here's the kicker. The actions field. It says generate _ EChallan. That right there is what makes this whole system automated and lets it scale across an entire city.
Okay, so we know the components now, right? But any real architect or engineer will tell you, building a system that actually works in the real world is about way more than just connecting the dots. So welcome to Section 3, an architect's checklist. This is where we really start thinking like an engineer and looking at the critical trade-offs.
And here it is, the first huge question you'd have to tackle as the architect. Edge versus cloud. What does that even mean? Well, it's about where the AI does its thinking. Do you process the video on the edge, meaning right there inside the camera itself? That gives you instant detection, which is super fast. Or do you stream all that video to the cloud, to a massive data center, for more powerful, centralized analysis? That's way more robust. It's that classic engineering trade-off. Do you need speed or do you need power?
And believe me, the tough questions do not stop there. These right here are the non-negotiables. Can your system scale from just one intersection to an entire city's worth of traffic? Is every single decision the AI makes totally traceable and auditable because you know it's going to be challenged in court? Can it hit its latency targets? We're talking detecting a violation in under 100 milliseconds. That's faster than a blink of an eye. And maybe the most important one, how are you protecting all that sensitive vehicle data? A good architect doesn't get to pick and choose. You have to solve for all of these. Okay, on to section 4, from blueprint to reality. We've got the grand design, we've got our tough engineering checklist, but how does a city actually take this complex plan off the paper and make it work on a real street corner?
Well, the smart way to do it is what people in tech call an MVP path. That stands for minimum viable product. Basically, you don't try to boil the ocean all at once. You start small. Maybe you target just one violation type, something simple like red light running. Then you prove it works. You deploy it on a single, really busy street and see what happens. Once you've got that down, you automate the ticketing and notifications. And then, and this is key, you measure the impact. Are violations actually going down? If the answer is yes, then you expand. It's a smart, measured, data-driven way to roll something like this out.
And that brings us to our final section, section 5, why this system matters. So let's pull back from all the tech specs and the engineering checklists for a minute and really zoom out to look at the big picture. What's the ultimate goal here? What's the real-world impact? And this quote, this really gets to the heart of it all. The system is as much about preventing violations as it is about capturing them. See, the ultimate goal isn't just to rack up fines. It's about deterrence. It's about creating a system that's so consistent, so fair, that it actually changes driver behavior for the better. It's about preventing the violation from ever happening in the first place.
And this is what success really looks like when it's all said and done. We're talking safer roads for you, for me, for everyone. It means more efficient enforcement that doesn't rely on just trying to hire more and more officers. It's a system that's constantly learning, using data to get better and better over time. And ultimately, yeah, it's about building genuinely smarter cities that can handle compliance and safety intelligently and at a massive scale.
Which kind of leaves us with this final big thought to chew on. You know, the blueprint we just walked through, it's not really just about traffic, is it? It's about embedding intelligence directly into the fabric of our cities. And that really makes you wonder, when our infrastructure can actually think, how will our cities truly change? That's something to think about. Thanks for joining me.